Here's the today we're going to solve in the application of differential calculus and optimization problems. So optimization problems are the problems wherein we tend to find the minimum and the maximum value that the function can take. So here's our example problem. Jamie wants to build a table. He needs a rectangular block that has a square base of side ACM, height of BCM, and a volume of 80 cm cube. The base and top are to be covered with lacquer costing 5 cents per cm squared, and the sides with lacquer costing 4 cents per cm squared. Find the values of A and B for minimum cost. So now we first draw the rectangular block. So, according to the problem, it is said that the base of our rectangular block is ACM. And this side said to be BCM. So now, in the given for our problem, is the volume of 80 cm cube, and the base and top to be covered with lacquer is 5 cents per cm squared. So the sides is 4 cm. So the sides is 4 cm cents, and the base and top is 5 cents per cm squared. Alright, now we solve for our function. So the upper function will be the function C. So C is equals to 5 times 5 came from the base and top, and then we need to times multiply the 5 cents per cm squared to the area of our rectangular block. So the area of our rectangular block is, as you can see, is A squared. But since we have two squares present in our rectangular block, we're going to times it by 2. So the area of the square base of this rectangular block is 2A squared plus 4 cents per cm squared, are given, and then we get the area of our rectangle here present, which is the side. So what is the area of the rectangle? It is length times width, which is in our case A, or A times B. But since there are 4 sides that are present in our rectangular block, we will multiply it by 4. So it will become 4 times 4 AB. Now, when are we going to use the volume? Since there's a B here, we can derive a formula for letter B. How? Using the volume. What is the volume of a rectangular block? The volume of a rectangular block is A squared B. And according to our problem, it is 80 cm cubed. Now, dividing both sides by A squared, cancel. B equals 80 over A squared. Now, substituting this one here and simplifying this will give us an answer of 20. Oh, sorry. It's 10 A squared plus 16A times our B, which is 80 over A squared. Now, simplifying this one, give us a 10A squared plus 16 times 80 is 1280 over 8. Now, we can actually reform this into, so that we can further differentiate it a lot easier. So we can use 10A squared plus 1280 times a raised to negative 1. Next, we will then apply the differential calculus. We will now get the derivative of c. Derivative of c using the power formula is 20a plus, oh, never forget the power formula. Since a is raised to negative 1, then we will minus 1 again, and then multiply it to the coefficient. So negative 1 times 1280 is negative 1280 times, since a is raised to negative 1 and minus 1 in the exponent. Now going back, since we minus 1 to our exponent earlier, it will then be equal to 20a minus 1280 times a raised to negative 2. Rearranging this would give us the answer 20a minus 1280 over a squared. Now to solve for our a, we will then equate this 1 to 0. Then equal to 20a equals 1280 over a squared. After that, going to multiply by a squared comes to 20a cubed equals to 1280. Multiply 20 a cubed equals to 64. Cube root, to eliminate the cube root of 64, 4. That's our final answer for our a. Now we have our value for a. Now we need a value for our b. Now going back to our equation in the volume, we will substitute the a. So b equals 80 over 4 squared. Came from here. Okay, now we will then answer 80 over 60 is equal to 5. Therefore, our a is 4 cm and our b is 5 centimeters. I will then give you 10 seconds to analyze and understand our problem. Thank you for listening and good night.